Hello everyone, welcome to EduVriddhi. I am Pranita Bedlur. In this present video, we are going to solve problems on distance, height and directions. This type of problems appear in CSIR NET General Aptitude Part A section. And before watching this video, it is better to watch video Part 1 of distance, height and directions because it contains theory and formulas related to solving these problems. And we have also covered 7 problems in the previous videos, and all the link of that videos will be given in the description box. Now let's begin. Next, question 8. A crow is flying along a horizontal circle of radius r at a height r above the horizontal ground. Each of a number of men on the ground found that the angular height of the crow was fixed angle, that is less than 45 degree, when it was closest to him. Then all these men must be on a circle on the ground with the radius. So here in this question, it is said that a crow is flying along a horizontal circle and that circle is having a radius r. So we will draw a figure for that. So this is the circle along which the crow is flying, and this is the circle of horizontal ground, and it is said that the circle in which crow is flying, it is at a height r above the horizontal ground. So if I take this as circle in which crow is flying, and it's given that it is having radius equal to r, and the horizontal ground, that circle, it is also having some radius, but we don't know that value. And it is said that the circle in which crow is flying, it is at a height of r from the horizontal ground. So if I take this as center, I'll join this. So this distance or this height is r. So let me name the radius of circle of crow as AO and the circle of ground as BC. So it is said that each of a number of men on the ground found that angular height of the crow was fixed angle. So if there were men on the ground, that is along the circle of the ground, if there were men, they found that the angular height of the crow which is flying in the upper circle, it is fixed, that is less than 45 degree. So let me take that angle as, or angular height as, theta. So if I join AB, I'll get ABC equal to theta, that is the angular height. And let me draw a perpendicular from point A on the line BC. So if I see, I'll name this as D. So if I see AOCD, it is like a square, okay. While drawing this figure, it looked like a rectangle, but actually see this adjacent sides are equal. So AO is R, OC it is also R, and in a square or in any rectangle we know opposite sides are equal. So since AO is R, DC will be equal to R, and OC is equal to R, AD will be equal to R. And our aim here is to find the radius of the circle of the ground. So then all these men must be on a circle on the ground with the radius. What is the radius of the circle which is representing the ground? So that we have to find, our aim is to find BC. BC is the radius of the circle of the ground. So that is to be found out. So for that, we already know BC is the sum of BD plus DC. We know the value of DC. It is given that it is equal to R. But we don't know the length of BD. So it is to be found out. So I will name it as X. So if you see this diagram, there is ABD. It is a right angle triangle. This angle is 90 degree. And here we have theta. And we know by formulas, we can put tan theta, cos theta, sin theta, anything. But if you see here, since this is theta, the opposite side is equal to R. That is AD equals to R. And the adjacent side is equal to unknown X. No need of considering here hypotenuse. Since hypotenuse factor comes in sin theta and cos theta, we can reject that formulas. Either we can use tan theta formula or cot theta formula. So let me use now tan theta formula to find out the value of unknown X. So we know that tan theta is equal to opposite by adjacent. And we know opposite value, that is opposite for this theta, ABD is equal to theta, and opposite for that we have side AD, so it is the opposite side, and AD is equal to R, and adjacent side is BD, we know it is unknown, so it is equal to X. Since we have to find X, we will get X is equal to R by tan theta. But if you see the options, this method is correct, but if you see the options, no such options are given, or everything is in the form of R plus R something. There is no fraction like R by tan theta, so we will reject this formula. Instead of that one, we will be using formula of cot theta. This formula is correct, we can use, but the option is based on cot theta, so we will be finding by using cot theta. So we have cot theta, that is the reverse of tan theta. Tan theta is opposite side by adjacent, so cot theta will be adjacent side by opposite. So cot theta is equal to adjacent by opposite. We know adjacent side is equal to X, that is BD, and opposite side is here AD, that is equal to R. Or what is R here? What is X here? X is equal to R cot theta. So we got the value of X equal to R cot theta. And we know that the radius of the circle of the ground, that is equal to BC. Okay, BD is not the radius of the circle of the ground. BC is the radius of the circle of the ground. So to find that radius, we have the radius of the circle of the ground BC is equal to BD plus DC. What is BD? X. What is the value of X? We have found out. We have found out it as R cot theta. And what is DC? We have already seen that it is equal to R. So we got radius of the circle of the ground BC is equal to R cot theta plus R, or we can say R plus R cot theta. So which is that option? It is nothing but option D. So option D, R plus R cot theta, is our answer. Question 9. There are two hills A and B in a region. If hill A is located north 30 degree east of hill B, what will be the direction of hill B when observed from hill A? North 30 degree east means 30 degree from north towards east. So it is given that there are two hills, hill A and hill B. And let us draw the figure first. So this is north, south, east, this one west. It is said that A is located north 30 degree east of hill B. So we will take this as hill B. This is hill B, this point as hill B, and to north 30 degree east. So this is north 30 degree. I'll take this as 30 degree. 30 degree, this is 30 degree. To east, that is this direction, we have hill A. So let me take this as hill A. And it is given that it is 30 degree towards A. So when you stand on B and watch hill A, it will be at an angle of 30 degree northeast. That is the meaning of that sentence. Now the question is, at what will be the direction of hill B when observed from hill A? From hill B, A will be looking like it is at an angle of, or in the direction of, north 30 degree east. Now if you stand in A and look towards B, what is its direction and angle? That is to be found out. So for that we will draw a parallel line towards north-south direction line. For this line, north-south line, we will be drawing a parallel line like this. So this is a parallel line. I will name this as D, and I'll draw another parallel line towards, which is parallel to east-west axis in this way. Okay. So if we see this diagram, so if this is 30 degree, if I will name this as ABD, this is C, okay. So if CBA, it is equal to 30 degree, then what will be BAD? That angle will be also equal to 30 degree because it is alternate angle. CBA and BAD both are, CBA and BAD both are equal to 30 degree because both are alternate angles. And if you see once again, if this is 30 degree, if CBA is 30 degree, what will be this one? We know that CBE, that is equal to, CBE is equal to 90 degree. It is understood. This angle, total angle is 90 degree. And CBE, it is nothing but sum of CBA angle and ABD angle. So if this is 30, 90 minus 30, this will be equal to 60 degree. ABD, that is equal to 60 degree. So if ABD is equal to 60 degree, what will be CAB? Okay, CAB will also be equal to 60 degree because these are alternate angles. If this is 60 degree, this will be also equal to 60 degree. So we got CAB is equal to 60 degree. So this is the angle when you observe hill B from hill A. So if you stand on hill A and observe hill B, it will be south 60 degree west to hill A. Okay, if you stand on hill A and watch towards this hill B, it will look like it is towards south. This direction is south and this is west. So it comes in this way. So it is named as, it is towards south 60 degree west. So that option is here. This one, second one, south 60 degree west. Question 10. An archer climbs to the top of a 10-meter high building and aims at a bird on top of a tree 17 meters away. The line of sight from the archer to the bird makes an angle of 45 degree to the horizontal. What is the height of the tree? So it is given in the question that there is a 10-meter high building upon which an archer is standing. Okay, an archer climbs a 10-meter high building. So this is the 10-meter high building. I'll name it as A, B. This is equal to 10 meter and archer is at the top of this 10-meter building. Now he is aiming at a bird which is present on the top of the tree, which is 17 meter away from the building. 17 meter away from the building there is a tree, and on this top of the tree there is a bird. I'll name this as C, D. So this archer is aiming at the bird which is present on the top of the tree, which is 17 meter away from the building, which is 10 meter. Now I will draw a horizontal. I'll name it as BE, which is parallel to AD. And it is also given that the line of sight of archer to the bird makes an angle of 45 degree to the horizontal. So if I consider BE as horizontal, the line of sight, that is when the archer looks the bird from here, he feels that it is at an angle of 45 degree to the horizontal BE. So that is the meaning of that sentence. So now our aim is to find the height of the tree. That is, we have to find the height of CD. So we know that CD is nothing but CE plus ED. So if you see this figure, this BEDA, it is a rectangle, and we know that in rectangle opposite sides are equal. Since BA is equal to 10 meter, ED will be equal to 10 meter. And since AD is equal to 17 meter, BE will be also equal to 17 meter because opposite sides in a rectangle are equal. So we got the value of ED. But to get the height CD, we need CE and ED. We have the value of ED, but we don't have the value of CE. For time being, we will name it as X. Now our aim is to first find out the value of this X. So once again, if you see here, there is a triangle, that is right angle triangle BCE. Here this 45 degree, it is theta. Now To this there is a opposite side, that is CE, or it's equal to X, and BE, that is equal to 17 meter, it is the adjacent side. So now we will put a formula on tan theta. So we have tan theta is equal to, formula for tan theta is opposite by adjacent. We have tan theta is here 45 degree, that's equal to opposite. What is opposite side? For this 45 degree opposite side is CE, that is X, and what is adjacent side? 17 meter, or it is BE. So we have tan 45 is equal to 1, that's equal to X by 17, or we can write X is equal to 17 meter. So we got the value of X, which is equal to 17 meter. Now our aim is to find the height CD, and we know that height CD, it is nothing but sum of CE plus ED. So we will calculate that one. We want height CD, that is sum of CE plus ED. What is CE? We have already found out, that is equal to 17. And what is ED? ED is equal to 10. So plus 10, I will get it as 27 meter. So this is the height of the tree. So it is, answer is option B, 27 meter. Question 11. Write D is equal to 1 degree, R is equal to 1 radian, and G is equal to 1 radian. Then which of the following is true? So there are different options from option A to D. We have to find which of that relations is true. So for that we have to know the relation between degree, radian and gradient. So we know that if you consider degree and radian, we have 180 degree, that's equal to pi radian. So if 180 degree is equal to pi radian, what will be 1 degree equal to? That will be equal to pi by 180 radian. And we know that pi, the value of pi will be nearly equal to 3.14. So this will be equal to 3.14 by 180 radian. So if you see this relation, 1 degree will be equal to 3.14 by 180 radian. So it is understood that 1 degree is always less than 1 radian, because 1 degree is 3.14 by 180 value of radian. So 1 degree is always less than 1 radian, or I can write degree, which is represented as D, it is always less than R. So you remember this relation, that is degree is less than radian. Next we will consider a relation between gradient and degree. It is given in the question, or if it is not given, we must be knowing that one. 100 gradient, that is equal to a right angle. 100 gradient is equal to right angle. So right angle is nothing but 90 degree. So we will get relation between gradient and degree, so that what will be 1 gradient, that will be equal to, if 100 gradient equal to 90 degree, then 1 gradient will be equal to 90 by 100 degree. So from this it is understood that since 1 gradient is equal to 90 by 100 degree, it is understood that 1 gradient is only 90% of 1 degree, or I can tell from this relation that D is always larger than G. Okay, from the first relation we got that D is always less than R. Now D is always greater than G. So from the first one we have D is less than R. Here we have D is greater than G. Now we will give the order, complete order for them. So which is the largest? D is lesser than R, but it is greater than G. So it will be in the middle. And largest one is R. And after that D, and least bigger is G. So we got the order. R is greater than D, which is greater than G. So if this is about the angle, just angle. Now if I consider cos of particular angle, we know that as theta value increases, cos theta value decreases. So if for angles, for just theta, if this is the order, if I consider cos theta, this will be reverse of this order, because as theta increases, cos theta value decreases. So that finally this order will be in this way: cos R is lesser than cos D, which is lesser than cos G. So search for this order in the option. So this is the option. Option C is the correct answer. Always cos R is less than cos D, which is less than cos G. Here is question 12. With reference to the right angle triangle shown, what is the value of sin A cos B plus cos A sin B? So there is a triangle given here which is having angle A and angle B, and it is a right angle triangle. We have to find the value of sin A cos B plus cos A sin B. So we know that we have a formula. Sin A cos B plus cos A sin B, that's equal to sin A plus B, or sin of A plus B. This is the formula. And let us try to find the value of A plus B from the given right angle triangle. So if I take any triangle, we know that the sum of the angles in any triangle, that will be equal to 180 degree. That is A plus B plus this one is 90 degree. It is represented plus 90 degree. That must be equal to 180 degree. And what will be the value of just A plus B? That will be equal to 180 minus 90. That is equal to 90 degree. So just A plus B, that will be equal to 90 degree. And it is asked to find the value of sin A cos B plus cos A sin B, but it will be equal to sin of A plus B. So we have the value of A plus B. A plus B is equal to 90 degree. So I can write sin of A plus B, that is equal to sin 90 degree. And what is sin 90 degree? That is equal to 1. So finally we found out the value of sin A plus B, because sin A cos B plus cos A sin B, that is to be found out in the question. That is asked. But by the formula, that itself is equal to sin of A plus B. So from the diagram we found out the value of just A plus B, that's equal to 90 degree. If I substitute that 90 degree in this formula, sin 90 degree will be equal to 1. So sin A cos B plus cos A sin B, that will be also equal to 1. So option B, 1 is the right answer. Thank you for watching the video.